I think we can go over to our larger discussion session. I would ask the other speakers of the session to join me here in front of this or at the front of the stage. And please, if you have any further questions to the speakers here or online, now is the time to ask them. I can maybe start one with a question to you, Ethan. I'm not very much an expert on the dust analysis, but with ion impacts, if you look at secondary charge particles, sometimes it can be challenging to quantify composition in comparison to just qualitative measurements. How big of an issue is that with the dust spectra?
So you're asking about secondary particles? Altered. So that actually hasn't come up quite a bit, but in our reflectron setup, sometimes really high velocity impacts, they'll create these really energetic and high temperature impact plasmas, and you'll actually have ions kind of overshoot your detector. And then as you can imagine, they go over to the other side of the target and then complete kind of 2 flight times. And so then when you look at the time of flight spectra for that, it's really skewed. So that's kind of something that we're looking to quantify, you know, what speed ranges are we dealing with that issue and kind of things along those lines. I actually had a question for you. You showed us those beautiful animations of the total precipitation. Can IEA provide flux, ion flux by composition? So how much H plus versus HE plus contributed to that?
Thank you. IEA cannot do this. IMA, the one that looks on towards the lunar surface, can. So it is possible to some sense. There's some additional, like the analysis codes that we're still working on. And then there's also the challenge of viewing direction. It has a 2 pi field of view, so it's very broad. So you can definitely see solar wind particles or ion outflows next to the sputtered and reflected populations. And there are some papers that report, for example, oxygen ion outflows. It is a bit more challenging, like I said, but I think it's possible. We have to spend a bit more time though. Any other question in the room, or do we have a question online?
No questions at the moment, no.
Okay, I have another one. Andrew, to you, you showed in one of your first slides the very nice TEM cuts where we saw the nanophase ion particles of the agglutinates. And when you compare nanophase ion particles and the size of the outer, or the size of them and the outer rim compared to essentially the boundary in the middle, those ones in the boundary section were significantly bigger than the ion particles in the outer rims. Is that something, or how, I was wondering how that works.
Great, thank you for the question. So my understanding is that with the creation of the agglutinates, it's multiple depositions of vapor deposited material and then larger energetic impactors, which do a larger melt and then fuse things together. So you end up burying some of the fine particles, which are on the outer part of that glassy bead, underneath other material. And so you get this multi-layered aggregate. And so sometimes the larger particles can be buried deep within it, whereas at the outer part we'll still have a exposure to vapor deposited rims with the very fine nanophase iron.
Thank you. Yeah, and I think it looks like, or do we have another question? Yes.
Sorry, I had a quick question for Alicia. I was wondering, I know that your work was a bit more on kind of the computational and simulational side, but when you're looking at your layered material, do you have any idea what the material properties of that would be? Is that something that, you know, if made, could easily be implemented into a spacesuit or other ways to kind of shield the astronauts, or are there other material properties that might have to be overcome?
Yeah, that's a good question. So for this material, we're looking at HDP and HBN, and both those are very lightweight, and so they can be flexible. And so it can be integrated into spacesuits. And because we're looking at additive manufacturing, they could also be additively deposited to make lunar habitats and stuff like this. So it has a wide range of applications. They could also have applications like outside of lunar stuff, and it could be used for more of medical work like on the Earth. And because we have not done the computation such that we've made it specific for the albedo lunar distribution on the it can be used to apply like for a wide range of lunar distributions. Does that answer your question?
Yes, I think now is a good time to conclude the session. I would like, or Addie?
I just want to say there's a dust, atmospheres, and plasma focus group at 12:45 in one of these rooms. It says on the agenda which one it is. Is it this one? In here. Perfect.
Okay, great.
Just before the dust session this afternoon. So please join, and there is a link for those online that I'll make sure people have.
Okay, yeah, great. Yeah, as I said, I would like to conclude the session. Thank you very much for joining us. And I would like to ask you to applaud once more for all the speakers. And thank you very much for all the nice presentations.